So today we're going to cover section 4, and we're going to learn 2 more shortcuts to prove triangles similar. They're going to be the side similarity theorem and the side angle side similarity theorem. These are the last 2. There's only 3. So it's not as many as the other one. There were 5 other ones. There's only 3 for the similarities. So let's see the first one. The first one is the side or SSS similarity theorem. And this states that if the corresponding side lengths of 2 triangles are proportional, then the triangles are similar. Now this has numbers, and we're going to confirm that all 3 sides are proportional, that they all simplify to the same ratio. So when we're taking this quiz or test, I'm not going to expect you to write SSS similarity theorem, but keep in mind that there's also the SSS congruence theorem. So if you see this on a standardized test and the question says, what would you use to prove the triangle similar? And if one of the answer choices is SSS congruency theorem, do not pick that one. You want the one that says similarity theorem. So know on a standardized test, the words after SSS would be important to you. But for this chapter for us, all we're doing is the similarity theorems. Now, they gave me this similarity statement so I could actually figure out what side matches with what. But let's say in the case that they didn't give me a similarity statement, I would match the largest with the largest over here if they didn't give you this. But we can also see that AC is the first and the last, and it's going to match with the first and the last here. So then I would do 10 over 5, 2 to 1. Then AB, first 2, match with first 2 here. So I'm going to do 8 over 4. And it also simplifies 2 to 1. And then lastly, BC to EF, 6 to 3. And that would be 2 to 1. So this is how you would show if 2 triangles are similar when you know the information about all the sides of both triangles. You're going to confirm that all 3 sides simplify to the same ratio. If they do, then the triangles are similar. The other one is now the side angle side. The last shortcut is called SAS, or side angle side similarity theorem. If an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides including these angles are proportional, then the triangles are similar. So the A that we're talking about in the SAS must be the angle that's in between the 2 proportional sides. It must be the included angle. So notice the sides that have numbers are making up that congruent angle. So again, I can confirm that the sides are proportional. I could put 10 over 5 and 8 over 4. Notice they both simplify to 2 to 1. And then the angle that is congruent is the included angle. Here is just a summary of the 3 shortcuts. You have the AA similarity postulate, the side similarity theorem, and the side angle side similarity theorem. Let's try some applications. So let's try the first example. Let me go ahead and draw these 2 triangles. So it says triangle ABC. And I have triangle XYZ. And let me draw it a little bigger. Okay, so it says the sides of ABC are 4, 5, and 7. And then the sides of XYZ are 16, 20, and 28. Now, it didn't tell you which way to put those numbers in. And they didn't give me a similarity statement, so it really didn't matter. And when I go to set up my proportions, I'm going to match the smallest number with the smallest of the blue and the red together, the two medium of the blue and the red, and then the largest. So for example, I would take the 4 and put it with the 16, because those are both the smallest number in each of their triangles. Yes, question? And then I would get 1/4. And then I could put the 5 with the 20. And then lastly, the 7 with the 28. Notice they all simplify to the same thing. So I could say, yes, these triangles are similar by the side, side, side similarity theorem. So notice we did not have any angle information. So that should have been a clue that we would be looking for side, side, side. Let's try the next one. It was part B here. So again, I'm going to draw ABC. And XYZ. So they want us to figure out, is ABC similar to XYZ? Now, this time they're telling me where to put the numbers. They told me AB is 2, AC is 5, BC is 6. And then XY is 2.5, YZ is 2, and XZ is 3. So they want us, and they gave us the similarity statement. ABC similar to XYZ. This is what they want me to check. So let's try it. AB with XY. So AB, XY. So 2 over 2.5. Then next, BC over YZ. And then the last one, 5 over 3. Now, this time I did not match smallest with small, medium with medium, because they gave me a similarity statement to check. Now, let's see if these simplify to the same thing. Soon as I find one that doesn't, then I don't need to go any further. So now for the red one, I could multiply them both by 10 and make this 20 over 25. And then simplify, multiply both or divide both of these by 5 and make this 4 to 5. This one, the blue one, simplifies 3 to 1. So I really don't need to go any further. Well, this one's already simplified. So notice I did not get the same ratios. So these are not similar based on this statement. Next. Now, for this one, I'm going to pull them apart because these triangles are overlapping. So it's telling me that if these are similar, so that would tell me the angles are congruent and the sides are proportional, it wants me to try to show that these triangles, will it follow and show that these are also similar? So let's go ahead and try it. So I'm going to pull it apart. So let me go ahead and trace over this. So I want XYQ. So I'm doing this one over here. So let me go ahead and write it over here. And it wants me to compare that to triangle XZP. So this one over here. Now, I know from my statement that angle X is congruent to angle X. I know that Y and Z are congruent, and P and Q, because they told me they were similar. Now, what I'm going to do in order to help us, and let me go ahead and show the other two triangles now, these right here, that I'm trying to show if they're similar or not. So let me go ahead and pull those off. So this XPQ is this little one in the top. And then XZY, the whole big thing. All right, everybody with me? Now, we can already see that the one that they're asking me to see if it works, I've already got angle X and angle X congruent because it's the same X in both. Now, what I need to do is I'm going to add in some numbers that would set up my proportions so I could see. So I'm going to add some numbers to this. 2, 6, 8. Anything as long as it makes it proportional. It doesn't matter what numbers you chose. Okay, so now I'm going to now transpose those numbers into the other triangles I just drew at the bottom. So I can see that side XP is 2. I can also see side XQ is 4. And then I can also see that side XZ is 6. And side XY is 12. They're asking me, is triangle XPQ similar to XZY? So now what I'm going to do is I'm going to match sides. So notice XP is going to match with XZ. So XP is 2. XZ is 6. This simplifies to 1/3. And then if I take the XQ, which is the first and the last, and I match it with the first and the last here, I'm going to do 4/12. Notice this one also simplifies to 1/3. So because the two sides that formed my congruent angle X are proportional, I could say, yes, it does follow that these triangles are also similar. And the reason is side angle side. So now it's asking us to name the similar triangles and give the postulate or theorem that justifies your answer. Good, angle, angle. They both share angle A, and they both have 80 degrees. So this would be angle, angle, similarity postulate. So these are yes. All right. So we could actually write a similarity statement here. We could say triangle ADE is similar to triangle same A, and then BC. Notice the D and the B both had the 80, and that's why I put those together. What about figure B? What can we use?
Side angle side.
Good, side angle side. They both share angle C. And let's check the proportionality of the sides. So for the smaller one, remember the larger triangle here, this has a side length of 9. This one on this side, it's 15. So I'm going to do 6/9, simplify that to 2/3, and then 10/15. And it also simplifies to 2/3. Now notice the included angle is the same in both. It's both angle C. So this is why it's side angle side similarity theorem. Let's try letter C. So again, this side here is made up of the 6 and the 6, so this has a length of 12. So let's go ahead and let's set up our proportions. So again, or our ratios, so the smallest number with the smallest number here, so 3/6 is 1/2. Then the medium number, which would be the 10, and the 5. So 5/10, and it's 1/2. And now the largest number, which is the 12/6. Now, if it helps you to pull them apart, you could also have redrawn them separated. So this one would be yes. We have shown that all three sides are similar. So our reason would be the side, side, side similarity theorem. Now I'm going to add one more or two more examples for you. And let's see if you can figure out if these things are similar or not. So let's say I draw what looks like my bow tie here. And let's say I add in 5, 6, 8, and 10. Can we prove that these are similar? No, right? We do have the vertical angle, and then I could try to set up my proportions. I could try 5/10, or even 5/8. Let's do it that way. Let's do small with small. So 5/8, 6/10, that would be 3/5. These are not the same fractions, so these are not similar. Now let's try another one. Same bow tie. 5, 10, 4, 8. Can I prove that these are similar? Okay, what would be my shortcut? Okay, let's check it out. Where's the angle that you're going to use? The vertical angle. Now, what do we know about the angle when it's side angle side? Where does it have to be? In between the sides. Is it in between the sides? No. So these are not similar. Now, if I would have told you that these angles were congruent, then I could double check my proportionality on the sides, and I could do 5/10, 4/8. They both simplify to 1/2. Now they're similar. But if I'm only trying to base it off the vertical angles, that is not the included angle, and you can't show that they're similar. Okay, so that is the end of 6-4. It is also the end of the shortcuts for proving triangles similar. And again, your quiz on Tuesday is going to cover 6-1, 6-3, 6-4. So you have time now where you can start your homework.